Okay, in this video, what we're going to be learning in this lesson is how to find the area of regular polygons. So this is a classic topic, and I'm going to get right into it. What we see right here is 5 different regular polygons that are the typical type of shapes that you'll be asked to find in geometry. So a square is a regular polygon. It's a regular quadrilateral because it has 4 sides. That's its fancy name, a regular quadrilateral. This is a regular hexagon. This doesn't have a name titled on it, but it's a regular pentagon. This is a regular nonagon, and this is actually a regular decagon, a regular nonagon because it has 9 sides, and decagon with 10 sides. Now, here in these shapes, we're given different information. In the regular hexagon and regular pentagon, we're given the length of one side. In this regular nonagon, we're given the length of what is called the radius. And this is called the radius because if you were to connect up the exterior points and draw a circle, and this is a poor drawing, but you can see that when you go from the center to one vertex, that's a corner, to one vertex, you are essentially drawing the radius of the circle. So this 11 is the radius. So this is called the radius, and I'll write R there. So when you go from the center to a point on the corner, which is called a vertex, you find that you have the radius. And then here, we're not given the radius in this decagon. We're given something that's called the apothem. And let me tell you why that's called the apothem. When you start at the center and go to the very middle of a side, notice how it's not going, this line is not going to a corner, but it's going to the middle of a side. That's called the apothem. So if I was going to come to this pentagon and draw the apothem, I would drop this line down right here, and that would be the apothem. So we have the apothem, we have the radius, we have the length of one side. Given just that length, we should be able to find the area of any of these regular polygons. So let's get right to it. And we're going to see we're going to see all of these examples actually. What's the main strategy? So here's the main strategy. Essentially, when you have a shape like a regular hexagon, what you want to do is divide the polygon into triangles because the area of each triangle is just 1/2 base times height. So we could take this polygon and slice it just like a pizza into triangles. And you'll create however many triangles will be the same as the number of sides. So a hexagon has 6 sides. Here's 6 triangles. And we're just going to say that the area is, and I'll write it up here, the area is just going to be 6 triangles, and each triangle is 1/2 base times height. And then that's pretty much what we're going to do for all these problems. To do this, though, you're going to have to find the base and the height for each triangle. Here, we know the base is 8, but the height would be down the middle, and the height is missing. So that's also the same as the apothem. I'm going to call it the height, but it is the apothem. And, well, we have to find that. Now, how would you find that? Well, you take the central angle and you divide it by 360 degrees by the number of sides. Because if you can find this angle, which is the same as this angle, same as this angle, this angle, this angle, this angle, those 6 angles are all the same. If you can find that angle, then you could use trigonometry or 30, 60, 90 or 45, 45, 90, or even the Pythagorean theorem to find the height or to find the base length of each triangle. So that's pretty much what we're going to do. We're going to find this angle that I have drawn in purple, and we're going to use that angle with trigonometry or one of these other shortcuts to find the base and the height. And then once we find the base and the height, we can multiply the base and the height times 1/2 times the number of triangles and find the area of the entire polygon. So we find the area of one triangle, then multiply by the number of sides. I'm just repeating what I just said. This is the area of one triangle times the number of sides. So let's do this right here with this polygon. So this is a regular pentagon. And let's do it. So what we're going to do is slice this polygon into equal triangles. So there we go, just like a pizza. And now what we have right here is we have 15. That's going to be the base length of one triangle. And then the height, well, let's draw in the height. And the height comes down right at a 90-degree angle, and it is through the center because this is an isosceles triangle. It's symmetric because it comes from a regular polygon where all the sides are the same. So because all the sides are the same, each triangle is isosceles. These two purple lines, all the purple lines are the same. Those are the radius. So that makes the height down the middle basically slice this into two equal triangles. So this is like, this whole purple triangle is one triangle. And when the height comes down the middle, it slices it into two equal triangles. And that's useful here. So let's first find the height and then find the area of each triangle and the area of the entire polygon. So how would we find the height? Well, remember what I said on the previous slide. What we can do is find this central angle by taking 360 degrees and dividing by the number of sides. So we're going to take 360 degrees, and that's because that's in the center, 360 degrees, divided by 5 sides. That makes for this angle to be 72, and let's label that angle. So each of these center angles are 72. Now, this center angle down here is also 72. However, the height drops down the middle, so we actually want to take that 72 and divide that in half. So divide that by 2, and that makes 36. And so what that means is that this small angle right here is 36. And that's so useful because now if I was going to draw this triangle larger, this bottom base is 15, drawing the height down the middle. This is 36 degrees. And now, we can use trigonometry to find the unknown height. So what would that unknown height be? Well, what we would do is say that this piece right here has a length of 7.5 because you take 15 and it gets cut in half. 15 divided by 2 is 7.5. Now we can find the height by doing trigonometry. So let's remember trigonometry. The very first thing you want to do is label the sides. So I would say, here is our triangle that I'm outlining in purple. Our angle that we're using as our main angle, our reference angle, is 36. So this is the opposite side to 36, go across. This is the adjacent side, and then over here is the hypotenuse. So what we're looking for is we're looking for the height, which is the adjacent side, and we know the opposite, which is 7.5. So when we use opposite and adjacent, that's tangent. So we're doing this work to find the height, and then once you know the height, we can find the area. So we're going to say that the area equals, wait, we're not done with that. Let's step back. We're going to say that the tangent, because the tangent uses opposite and adjacent. So we're going to say that the tangent of 36 degrees equals the opposite over the adjacent, which is 7.5 is the opposite side over the adjacent is h. So we're going to just solve for the height right here, the h. And the tangent of 36, when you look that up, is 0.7265. And then we could multiply both sides by h. So we could also cross multiply, but we're going to get 0.7265h equals 7.5. That would be the same thing if you cross multiplied from over here. And then you would divide by 0.7265 on both sides. And you're going to get that the height of the triangle is 10.32. 10.323. There you go. So what did we just do? We just said, all right, we're going to find the area of this whole shape by breaking it into 5 triangles. Here's one of the triangles. We used tangent with an opposite over adjacent. Because it's opposite over adjacent, we use tangent. And we found that the height is 10.32. And now we're going to use that 10.32 to find the area of the entire polygon. And it actually works out pretty easy. So the area of the entire polygon is going to be 5 triangles. So each triangle is 1/2 base times height. And so the base of each triangle, be careful, don't take the 7.5. Take the entire base, which is 15, because we're finding the area of one of these whole pizza slices. So one of these entire triangles. And so the area is 15. I mean, the base is 15 and the height is 10.323. And let's multiply this. Now you could multiply this all together with the 5, but I want to leave the 5 separate because conceptually, I want to discuss that in a second. So let's multiply this. So 15 times 10.32 is about 150. Then half of that comes out to be 77.4. So 15 times 10.323 times 1/2 is 77.4. What is 77.4? I hope you realize that 77.4 is the area of one triangle. So this area is 77.4. And then times 5 is the area of the entire polygon. And the area of the entire polygon would be 387. That's just 5 times 77.4, 387 units squared. And that would be like feet squared or meters squared or whatever your units are. Oh, hey, our units are feet. So we're going to put feet squared. All right, in our next example, we have a very similar problem, except obviously this shape has more sides, and we're not given the length of one side, but we're given the height of one of our triangle slices. In other words, we're given the apothem. This line down the middle has a length of 0.5. This is not the radius. The radius would go from the center to a vertex. So the radius would go from here to here, or the radius would go from here to here. But this is the apothem, and the apothem is actually a little bit shorter than the radius because it doesn't reach as far all the way to a corner. It just reaches right to the center. Anyway, we're given the apothem as length 5, which is like the height of one triangle, and let's find the area. So let's actually start our work with our final step. The area is going to be, well, what is this area going to be? How many sides does it have? If you count carefully, it'll have 10 sides, so it's going to be 10 triangles, and each triangle is 1/2 base times the height. And the height for each triangle, we could even put in right now. It's 5. The height has a length of 5. Now we're going to work to find the length of each base, which is right here. How long is that base? Well, I like to kind of draw one of these triangles separately, and we're going to use trigonometry or another shortcut to find the length of the base. So let's do that right now. So the concept is we split this into triangles, and this is going to make 10 triangles. Do you count those? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And how much will this angle be? That's the first step. Well, remember what we did in the previous problem. 360 divided by how many are there? There's 10. So 360 divided by 10 makes each central angle 36 degrees. So this is 36 degrees, 36 degrees, and so on. Now, in the triangle, when we drop the height down, the height slices down the middle. So we also have to realize, and like we did the same thing in the previous problem, 36 divided by 2 is 18 degrees. So this angle right here is 18 degrees. So, and that's, I'm sorry, that's a very small 18, but hopefully you can still understand or see. That is 18 degrees. Okay, so that angle is 18 degrees. And now we can do, well, we'll have to do trigonometry because all we know is that this length right here is 5. And then we're looking for the base. So when we do our trigonometry, we're going to work on this triangle right here. And our 18 is our reference angle. So this piece down here is the opposite, which we'll call x. And then whatever x is, we'll just times it by 2 to find the base, because this is x and x times by 2 to find the base, because both of these pieces are the same. We'll just double it to find the base. I'm being repetitive. And we know the apothem, the height, is 5. So let's label our triangle to do our trigonometry. So this is 18. That's our reference angle. We labeled our opposite. This is our adjacent again. Our hypotenuse would be this side, but we're not going to really use it. And so we're going to say that the tangent, so we are using tangent again because that's opposite and adjacent. So the tangent of 18 degrees equals x over 5. And we're doing this work so that we can find the length of x, which will be the length of the base, or double it to find the length of the base. So the tangent of 18 is 0.3249. And that, just solving this. So I looked up tangent 18 on a calculator, and that's the ratio of tangent of 18 is 0.3249. Then we're going to just times both sides by 5 to eliminate that. And 5 times 0.3249 is 1.624. And that is x. Now, how much is the base? Well, the base is just 2 times x. So it's 2 times 1.624. So really, all we're doing is just doubling x to find the whole base. So 2 times 1.624 is 3.25. Okay, now we're ready to find the area of this entire polygon. So the area would be 10 triangles. So 10 times each triangle. Each triangle is 1/2. Base, the base is 3.25 times the height, and the height of each triangle we already were given is 5. And now we just multiply this and multiply by 10, and we are going to find our area of our polygon. So 3.25 times 5 times 1/2 is 8.1225. And then that's getting times by 10. And then that multiplied by 10, you can just move the decimal one time. So 10 times 8.1225 is 81.225. And there's no units here. So here we would actually say that would just be 81 units, 81.225 units squared. And that's the area of this shape. Now, one thing I wanted to discuss here just very briefly is you can kind of use common sense to check that. Would this shape actually have an area of about 81? Well, let's imagine that what we have here is this is 5. So this whole distance here, if I was going to double that, 5 and 5, that would be 10. And we could actually then imagine, what if I just sort of sketched a square where the height was 10? So that'd be 10, and that'd be 10 because it's like a square. So if I put this inside a square, this would be like a total height of 10, a total width of 10, 10 times 10. So the whole area of this square is 10 times 10, 100. And so then the polygon fills up most of it. About 81 units out of those 100, because 10 times 10, because this polygon looks like that's about 81 out of 100, because 10 times 10 makes 100. So that kind of makes sense. So you can kind of use, imagine shapes that are around it, that are close to it, that might help you guesstimate to check your answers. Anyway, that was all unnecessary, but hopefully helpful. So yes, the area of this regular decagon is 81.225.